Now let's take a look at how we code a dense layer in using TensorFlow or Keras. Um, Here is a sample dense layer I have written, and here is the input layer, and here is a layer with three nodes in them. And as you know that the weight matrix would be 2 by 3. So you'll have W11, W12, W21, W22, W31, W32, 32, and then you will transpose it and then multiply it with the input. I'm just going to give an example of 2 and 1 as an input, or 1 and 2, 1 and 2, right? 1 and 2, and then we will have a bias which I'm not connected just to reduce the clutter on the diagram. B would be 0, 0, 0, and then we should get an output of some dimension. Let's take a look. If you transpose this, it will be it is 2 by 3, it's going to be 3 by 2, and this is 2 by 1. We add 0, 0, 0 plus 3 by 1. We should get 3 by 1 matrix as an output, which is correct in terms of our calculations. So I'm going to take an example and see how we can code this in TensorFlow. So I've already coded this. Here's an example of notebook. I'm going to link the GitHub where you can download this notebook, but these examples are so simple you can just type it in. So if you have not installed TensorFlow, you may want to install that. Once if you install it, here is a Keras dense layer. You would first import TensorFlow Keras layers. Dense is a layer, so from layers you're going to import a dense layer, and then I'm also going to import NumPy because I'm going to pass the NumPy input through this dense layer. So I will define a dense layer by saying, because this has three nodes in them, so first parameter is going to be how many nodes that I have, 3 nodes, and then I will just use a linear activation just to demonstrate what's really going on. And then the input shape is 2 because we have 2 inputs. And then I'm going to use the bias. You don't have to use the bias if you don't want to. You can also name the layer. I'm just going to call this as F. In the long chain of things that you may call it as layer 1, layer 2. By default, dense layer gets a name, layer 1, layer 2, but I'm just deciding to show that you can give it a name. So X is a input variable, as we talked about, 1, 2. I'm going to initialize it, and I'm going to pass it through. One pass through the dense layer is just calling D with the value of the input. So dx will pass this input through this weight matrix, and then you can check the weights. If you check the weights without passing the inputs, it will give an error. So d.weights or d.getWeights, they both are the same. So let's take a look at the output. So the weights are randomly initialized. Here is a matrix with 2 by 3, and then the B is 0, 0, 0. So now let's initialize our own matrix with our own weights. Not that you need to take the randomly initialized one. Just to show that the calculations are as we expected, I have created an array with 1, 0, 2, 1, and 3, 2, and with the bias of 1, 0, 0, 0. I'm going to set the weights, and then I'm going to check the weights here. So the weights are what we passed in. So for this particular example dense layer, I have the weights set as 1, 2, 3, 0, 1, 2, and B as 0, 0, 0. So let's take a look at what should we expect the output with 1, 2 as the input. So this is 1, 2, 3, 0, 1, 2, and then we pass it through 1 2, and then we transpose this, right, 0 0 0, and then we should get some output. Let's take a dimension of this output. So this is 3 by 2, this is 2 by 1, and we are adding with 3 by 1. Therefore we should get 3 by 1 output. So let's do the calculations. This is I want to rewrite this as 1 0 2 1 3 2 multiplied by 1 2, and I'm not going to add b just because to save time. This is 1 times 1, 2 times 0 is 1, and then 2 times 1, 2 times 1 is, we add those two, 4, and then 3 and 4 makes it 7. So this is what we should expect as an output, 147. Let's see if we get that output. We set the weights and we pass it through, and then the output is 1 by 3, or the transpose of that would be 147. So it seems to be working as we are expecting. So you can code this small little dense layer, convince yourself that this is actually doing what you expect or learned in terms of forward propagation, and then we will build a lot more complex layers in the future videos.